is Julia. I'm from Brazil and I'm currently a student of PPCR 2020 Principles and Practice of Clinical Research. And finally guys, I made it. Let's do a review of Module 2 Basics of Statistics, and the bibliography I'm using is our course book, Critical Thinking in Clinical Research. Look guys, I'm a student, I'm not a TA, okay? So critical thinking while watching these videos. Okay guys, so in this video I'm gonna talk about statistical tests, but I'm gonna give you just some general concepts so we can further have a better understanding on statistical tests properly, okay? So first, what are statistical tests? So those tests aim to confirm or reject a hypothesis, right? Well, so first we need to know if the difference we collected in our results in our study, the difference in effect, for example, of a drug A and drug B, can be four factors. The real effect, so I can say that drug A has a different effect of drug B, can be due to chance or coincidence, so that is why we have the p-value. We have to have a range of acceptable errors. It can be due to confounders or biases, and here guys it is important to emphasize that statistical tests do not account or do not account for these two factors. So how can we reduce the chance of having a different effect between groups due to these factors? Well, we have then to choose a proper study design. That is the main importance of choosing a proper study design, okay? Well, so let's go now to our statistical systematic errors. So we have two kinds of systematic errors. Type 1 error, also called as false positive. Why? Because we have a true null hypothesis. Null hypothesis is true. Drug A has no different effect than drug B, but we reject it. So we said that drug A has a different effect than drug B. Well, it is false, and that is actually more consequential than type 2 errors because we are establishing a relationship, and that could alter several, for example, protocols in several fields. So that is really consequential. Well, so we need to control type 1 errors, and how do we do that? With p-value. So what is p-value? P comes from probability, so it is the probability that the difference in effects between these two groups, drug A and B for example, it is due to chance. So p-values measure the chance of having that the difference effect between groups is just a coincidence. So if it measures coincidence, the lower p-value, the better, right? Yeah, that is why we have only the range of acceptable type 1 errors is only 5%, 0.05. So one among 20 trials may establish a false relationship between difference of effect and an intervention, okay? Well, so p-value is related to two things. So sample size and the effect itself, obviously. Well, so sample size. If I have a too small sample size, I may not have the power to establish a relationship, right? And that would increase actually type 2 errors, but I'll explain in further details. And if I have a too large sample size, then I'll have like too much power. Then small differences that are meaningless in the practical and clinical practice, for example, they have like a strong effect if I have large sample size. So then I can increase my chance to establish a relationship when there is no relationship in reality, right? So that larger sample size, too big sample size, can increase my chances of type 1 error, false positive. And the p-value is also closely related to the level of significance, represented by an alpha. And the level of significance is exactly the amount of permitted type 1 errors that each study can make. Okay? Well, in simply speaking, okay? Well, and then we have type 2 error. Type 2 error is also known as false negative. And what is it? Well, is when we have a false null hypothesis. So drug A has a different effect than drug B. It can be better or worse. But we fail to reject the null hypothesis, right? So these type 1 errors occurs because the study is underpowered. And how the study can be underpowered? Small sample sizes, for example. So I don't have too much examples to say it and to confirm that no, drug A is better or worse than drug B. Well, so remember that null hypothesis is like the two interventions, maybe intervention and control or whatever. The null hypothesis states that these two interventions don't have any different effect in the groups, right? So the effect of both of interventions are the same. And the alternative hypothesis states right the opposite. So the intervention does have one intervention has a better or worse effect than the other, right? So we can actually state that our alternative hypothesis can be two-tailed or two-sided, which this statement doesn't have any side, any direction. So the one intervention, for example, drug A, can be better or worse than drug B, while one-sided or one-tailed alternative hypothesis state the direction. It has to be or better or worse than the other drug B, for example. Okay.